Hi everyone. In this week's module, we're going to focus on thermal comfort. And I'm going to split today's lecture up into three parts. First, we'll talk about thermal comfort. What is it and what factors affect a person's thermal comforts? Next, we'll move into the psychrometric chart, what it is, how to read it, and then map our comfort zones onto the psychrometric chart. And in the third section, we'll talk about different comfort strategies and how to adapt the environment, both personally and in a building, to provide comfort. We'll end up with the bioclimatic chart. That's what's shown on your screen right now. And by the time you get all through this, that confusing looking chart, it's going to be no problem. So let's get started. So, thermal comfort. Your textbook has this great quote at the beginning of your chapter. It says, thermal comfort is that condition of mind which expresses satisfaction with the thermal environment. So, I've got this great illustration here of a cat on a hearth. That cat is experiencing thermal comfort. The sensation of comfort is individual and it will vary from person to person. And multiple factors go into that sensation of comfort. We're going to split them into kind of two categories, the personal factors and the environmental factors. So first, personal factors. These are things that are individual to your building occupants. They might be able to be influenced by that occupant or maybe not, but they are not able to be influenced by the architects. All right, and that is metabolic rate, how fast a person burns energy, and this can be affected by age and by gender. Activity level, what that person is doing, are they exercising or are they sitting still? And their level of clothing or the insulation that's on their body. So here's an illustration of that. We have a child and a grandfather sitting together on a bench. They're doing the same activity level, right? They're both sitting still, but they have different metabolic rates. And therefore, if you notice, they have chosen different levels of clothing or insulation to bring their personal body into thermal comfort. Let's move to the environmental conditions that affect thermal comfort, and they are air temperature, relative humidity, air movement, and mean radiant temperature. Air temperature is our first factor. This is a familiar measure of thermal comfort. Is it hot outside? Is it cold outside? All right. It's measured in degrees Fahrenheit or degrees Celsius. And it's also called dry bulb temperature. So if you see any records that say this is the dry bulb temperature, what they're meaning is the generic or general air temperature. Your human comfort range is going to be roughly 68 to 78 degrees Fahrenheit, which is 20 to 25 degrees Celsius. It is a wide range, and that range it's that large usually because people adjust their clothing to be comfortable within that range. Now, all of these ranges of human comfort that I'm giving you, um, remember that they are individual to the person, and the ranges are set to make 80% of the population comfortable. All right, so there will be outliers. There will be people who are not comfortable. These are generic comfort ranges. Our next environmental factor in thermal comfort is relative humidity. It is the amount of water in the air relative to the total amount the air could hold at that temperature. And therefore it's measured in a percentage. Human comfort range is roughly in the 20 to 80% range, so this is a wide range. In general, you definitely want to be above 20%. And the top range kind of varies with the temperature and the season. You want to be below about 60% in the summer, below about 80% in the winter. Again, remember this will make roughly 80% of the people comfortable. So let's make sure you really understand this absolute versus relative humidity kind of question. Why is it relative humidity? Well, it turns out that the amount of water that the air can hold goes down as the air gets cool. All right, so warm air can hold a lot of moisture. Cool air can only hold a small amount of moisture. So the absolute humidity at any time is the amount of water that's in the air. The relative humidity at any time is the percent of the water in the air compared to the total amount that the air could actually hold at that temperature. Still confused? Let's take a look at this little illustration here. We've got two different size containers. Right? And they have the same amount of water in them. So the one on the left, okay, is 50% full. The one on the right, even though it has the same amount of water, the same absolute amount of water, it is relatively less full. It's only 25% full. So let's continue the analogy and say that on the right here we have your air in the summer, so it's warm air, and it's got this amount of water floating in the air, suspended in the air. It would have a 25% relative humidity. On the left might be your air temperature in the winter. You're only able to carry this smaller amount of water. So with the same absolute humidity, the relative humidity is higher. It's 50% instead of 25%. Our third environmental factor in human comfort is air movement. And this is another way of saying ventilation or wind or breeze. And it's measured in air velocity in feet per minute or meters per second. Our human comfort range is somewhere in the 20 to 60 feet per minute. And your textbook, way in chapter 10, has this interesting chart of air velocities and thermal comfort. So take a look. The last environmental factor in thermal comfort is called mean radiant temperature. And this was introduced in last week's chapter. And it affects human comfort with the sensation of being exposed to hot or cold surfaces. So if you have ever sat near a window when it's very cold outside, you will know what I'm talking about. It's not the air temperature. You're not being exposed to the outdoor cold air. It is the mean radiant temperature of that cold window pane that is affecting you. Mean radiant temperature is directional, so you'll see some equations. Your textbook has some equations for determining a average mean radiant temperature. That's what mean means, for a specific location in a room. But it turns out that also people will feel that directionality. So even this person here in this room that has a fireplace on one side and a cold window on the other side, they're not going to feel that mean temperature. They're going to feel hot on one side and cold on the other. All right. So in general, our goal for human comfort, human thermal comfort, is to maintain your mean radiant temperature close to the ambient air temperature. All right, everybody, in this video, we covered thermal comfort. What is it and what are the main factors that affect it? In our next video, we're going to take a look at a psychrometric chart.